Welcome to the deep dive. You're here because you want to get up to speed on AI fast. And today, we're really focusing in on these terms you hear thrown around, AI agents and agentic AI.
That's right. Things are moving so quickly, it's easy to get lost in the terminology.
Exactly. So we've got this research paper, AI agents versus agentic AI, a conceptual taxonomy, applications, and challenges. And our mission really is just to pull out the core ideas for you.
Yeah, we want to unpack what the paper says about the key differences, what these things can actually do, and, the challenges they still face.
All based strictly on this paper, giving you a solid understanding without you having to wade through all the technical jargon yourself.
The paper provides a really useful way to think about this. It helps clarify things that often get mixed up.
Okay, so let's dive in. The paper starts by saying, hey, this idea of autonomous agents, it's not brand new, not just since ChatGPT. It actually goes back quite a bit.
Right, it points to older fields like multi-agent systems, MAS, and even expert systems. There's a history there.
And it mentions some specific foundational work.
Yeah. People like Castelfranchi looking at how individual agent actions add up to social behavior, and Ferber's work on frameworks for these multi-agent systems. They were thinking about autonomy, perception, communication way back.
So those were the early ideas. But the paper draws a pretty clear line between, say, an old expert system like MYCIN.
Right, or the Stanford card, even AI and old RPGs.
And the AI agents we're talking about now, what's the main difference the paper highlights there?
Well, those older systems were very much rule-based, like if X happens, do Y. Very scripted, as you said. They couldn't really learn or adapt much beyond their programming.
Whereas today's agents?
Today's agents, according to the paper, are much more driven by learning from data. They can understand context better, adapt more dynamically. It's a big shift from just following rules.
Okay, and this is where it gets really interesting according to the paper's data. It shows this huge spike in interest, like on Google Trends, for both AI agents and agentic AI starting late 2022.
Right around the time large generative models really took off. The ChatGPT era, as the paper calls it.
It wasn't just hype then. The data suggests a real shift.
Absolutely. The paper argues this shows a change in how people saw AI's potential, moving from something theoretical to something people were actively trying to build and use.
And the paper traces this evolution, right? Post-ChatGPT, it talks about phases.
Yeah, sort of three ways. First, these generative agents that ChatGPT made popular, then the AI agents we're focusing on, and finally the more complex agentic AI.
And it gives examples we'd recognize, like GitHub Copilot or Jasper starting out.
Those fit more into the generative agent category initially.
Yeah.
Then you see things like AutoGPT, Baby AGI, Crew AI coming along, pushing toward more agent-like behavior.
So let's nail down that core distinction the paper makes. AI agent versus agentic AI. What's the fundamental difference?
At its simplest, the paper defines an AI agent as typically a single system focused on a specific, well-defined task. Think of it like a specialist tool.
Okay, one agent, one job, basically.
Pretty much. Whereas agentic AI, the paper explains, involves multiple agents working together, coordinating to handle broader, more complex workflows. Things one agent alone couldn't manage.
Like a team versus an individual.
Exactly. And the paper really emphasizes why getting this distinction clear, having a proper taxonomy, is scientifically important.
Why does that matter so much? Just semantics or?
No, it's more than that. The paper argues it helps with, designing systems better, whether you need a single agent or a whole team. It helps with benchmarking, too. How you test a single agent is different from testing a collaborative system.
Avoids confusion and wasted effort, basically.
Right. Using the right approach for the right problem.
Okay, let's dig into AI agents then, based on the paper. How does it formally define them?
The paper describes them as autonomous software entities designed for goal-directed tasks within specific digital environments, bounded environments.
And it highlights key characteristics. I think figure 4 in the paper showed this.
Yes, exactly. Autonomy, they can act independently once set up. Task specificity, they're built for narrow, defined jobs like scheduling or maybe filtering data.
And reactivity and adaptation.
Right. They can respond to changes in their environment and sometimes learn from feedback, like a recommendation engine getting better over time.
And the paper stresses the role of those big foundational models, LLMs and LIMs.
Hugely important. LLMs, like GPT-4, provide the reasoning power, the language understanding. That's what lets an AI support bot understand your question and plan a response.
And LIMs, like
They bring in the visual side, so an agent can understand images, like the paper's example of a drone inspecting fruit in an orchard using image recognition.
Yeah.
That's figure 5, I believe.
And access through APIs plus frameworks like LangChain or AutoGen that's made building these agents easier.
Definitely. The paper suggests these tools lower the barrier to entry. Developers can leverage these powerful models without building everything from the ground up.
Now, the paper positions generative AI, like basic ChatGPT, as a sort of precursor. What are the key limitations it points out?
Well, the main thing is reactivity. Generative AI responds to prompts, but it doesn't act on its own. It lacks that autonomy.
Yeah.
And it's usually stateless. It doesn't remember past interactions unless you specifically feed them back in.
It needs to be told what to do every time.
Pretty much. It's amazing at creating content, but it's not a proactive problem solver in the same way an agent aims to be.
So those limitations, handling ongoing tasks, remembering things, needing external tools that led to the development of these more capable AI agents.
That's the progression the paper outlines.
Yeah.
AI agents build on the LLM's language skills, but add memory, planning, and crucially, the ability to use external tools.
Right, the tool-augmented part. The paper says LLMs became the engine for this.
Yes, they're repurposed. Not just generating text, but interpreting goals, planning steps, using tools. The paper mentions frameworks like React.
What's significant about React?
It formalizes this loop. The agent reasons, then acts, maybe by calling a tool, then observes the result, and uses that observation to inform the next cycle of reasoning. It's much more dynamic than just thinking and then doing one thing.
Makes sense. And the paper gives examples like AutoGPT for market analysis or GPT Engineer for coding. Figure 6 shows a news query agent workflow, too.
Yeah, those examples show how combining LLM reasoning with external tools lets these agents actually do things, gather information, execute tasks, solve problems in a more active way.
Okay, so that's AI agents. Now let's shift to Agentic AI. The paper says this emerged to tackle limitations of single agents, right?
Exactly. When you have really complex problems, multi-step workflows, or tasks needing different kinds of expertise, a single agent might struggle.
So Agentic AI is the next step up.
It's a conceptual leap, as the paper puts it, moving from one agent doing its job to a system of agents collaborating, multiple specialized agents working together towards a higher level goal.
And they coordinate how? Centrally or?
Could be either, according to the paper. Maybe a central controller directs the others. Or they might communicate and coordinate more directly among themselves, using things like shared memory or messaging.
And key enablers mentioned are things like breaking down goals, multi-step reasoning, communication between agents.
And reflective reasoning, yeah. Those capabilities allowed the system to tackle much bigger, more intricate challenges.
The paper uses that smart thermostat versus smart home analogy in Figure 7.
That's a great illustration. The thermostat is like the single AI agent-specific task. The smart home ecosystem, with everything working together, is like agentic AI.
And Table I in the paper really breaks down the differences.
Yes, Table I is key. It compares them on definition, autonomy, task complexity, collaboration needs, learning, applications. It systematically lays out how agentic AI represents a step up in complexity and coordination.
And there are more tables 2, 3, 4b going into even finer detail, like how they're initiated, goal flexibility.
Right. Those tables provide a really granular comparison. For example, Table 2 highlights that AI agents usually need an external trigger, while agentic AI might initiate actions based on internal goals or environmental cues, more proactive.
Gives you a really detailed framework.
Absolutely. Very useful for researchers and developers trying to categorize and understand these systems precisely.
Okay, architecturally speaking, how does agentic AI build on the basic AI agent structure? The paper mentions Figure 8 here.
So the basic AI agent has that perception, reasoning, action loop, maybe some simple learning. Agentic AI takes that foundation and adds layers.
Right.
Like having an ensemble of specialized agents instead of one generalist. Using more advanced reasoning techniques, the paper mentions things like chain of thought or tree of thought, having more persistent structured memory. And crucially, adding an orchestration layer.
Orchestration, like a conductor.
Exactly. Sometimes it's even called a meta-agent. It manages the interactions between the specialized agents, assigns tasks, ensures they work together coherently. Think of ChatDev's virtual CEO role, as mentioned in the paper.
So it's not just more agents, it's a more sophisticated structure for managing them, like going from that Swiss Army knife to a full managed toolbox.
That's a perfect analogy for how the paper presents the architectural evolution.
Let's talk applications. Where does the paper say we're seeing these systems used? Figure 9 gives an overview, right?
Yes. For AI agents, it's things we're starting to see commonly. Customer support bots, internal company search tools. Think Salesforce Einstein or Intercom Fin.
Email filtering, personalized recommendations on streaming sites or e-commerce.
Right, Amazon, Spotify. Also basic data reporting, like with Tableau Pulse or Power BI Copilot. And autonomous scheduling assistants. The paper mentions X.AI, Reclaim AI. Figure 10 shows some scenarios.
So mostly automating specific, often repetitive tasks.
That's the focus for single AI agents according to the paper Efficiency Games, Handling Defined Functions.
Okay, and agentic AI applications. These should be more complex, collaborative tasks based on what we've discussed.
Exactly. The paper points to examples like multi-agent research assistants using AutoGen or Crew AI to help with complex tasks like literature reviews or drafting grant proposals.
Like the NSF grant proposal example in Figure 11A, what else?
Intelligent robotics coordination. Think multiple drones or robots working together in farming or warehouses. The paper uses an apple orchard harvest as an example in Figure 11B. Also, collaborative medical decision support systems in hospitals.
Helping doctors with diagnostics or treatment planning.
Potentially, yes.
Right.
Pilots are being explored. And then there's multi-agent game AI, making games more dynamic, and adaptive workflow automation for complex processes like cybersecurity incident response, as shown in Figure 11D.
So these applications really lean into that collaborative, multifaceted problem-solving capability.
Definitely. They tackle things that are just too big or require too many different skills for one agent alone.
But it's not all smooth sailing. The paper dedicates a good chunk to challenges and limitations. Figure 12 compares these.
It does. For single AI agents, the paper flags issues like a lack of real causal understanding. They're good at correlation, not always cause and effect. They inherit limitations from LLMs, like hallucinations or biases.
And sometimes they aren't fully autonomous or proactive. Incomplete agentic property, as the paper calls it.
Right. Plus, they can struggle with really long-term planning, error recovery, and there are still reliability and safety concerns, especially for critical tasks.
So they're powerful, but brittle in some ways, and maybe not fully trustworthy yet for high-stakes stuff.
That's a fair summary of the paper's points. And for agentic AI, these problems often get amplified. Communication bottlenecks between agents can arise. Coordination can fail.
And you get emergent behavior, stuff you didn't predict.
Exactly. Unintended consequences from complex interactions. Scalability is harder. Debugging is harder because it's like multiple black boxes interacting. Trust and explainability become even bigger issues.
Plus, security risks increase, ethical governance gets more complex with multiple agents, and the paper says the foundations are still immature.
Yeah, there's a gap between impressive demos and really principled, robust design. Lots of research challenges remain in coordinating these systems effectively and safely.
Okay, it sounds daunting, but the paper also offers potential solutions and a roadmap forward. Figures 13 and 14.
Yes, it outlines about 10 emerging solutions. Things like retrieval augmented generation to make LLMs more factual, using tools more effectively via function calling, improving the agentic loop, that reason-act-observe cycle.
Better memory architectures, specializing roles for agents in multi-agent systems.
Also, adding self-critique mechanisms so agents can check their own work. Better prompt engineering, using causal modeling for planning, and building and monitoring and explainability from the start.
And governance-aware architectures.
Right. Designing systems with accountability and role isolation in mind for ethical reasons.
And the roadmap in Figure 14 sketches out the future.
Yeah, for AI agents, it points towards them becoming more proactive, better integrated with tools, developing causal reasoning, learning continuously, and becoming safer.
And for agentic AI.
The roadmap emphasizes scaling multi-agent systems, better orchestration, shared persistent memory, using simulations for planning, establishing ethical governance, and creating domain-specific systems tailored for particular industries or problems.
Okay, so wrapping this deep dive based on the paper, the core distinction: AI agents are typically single entities for specific tasks. Agentic AI is about multiple agents collaborating on broader goals.
And we've traced the evolution: foundational AI, generative AI, then AI agents, and now these emerging agentic AI systems.
Both have huge potential, clearly, across so many areas the paper touched on. But,
as the paper makes very clear, there are significant hurdles still to overcome in areas like reliability, coordination, safety, and explainability before that potential is fully realized.
which really leaves us with something to think about, based purely on what this paper presented. Reflecting on these two paths, the single-focused AI agent versus the collaborative agentic AI system,
Right.
which direction do you think based on the challenges and potential solutions outlined here, holds more promise for tackling truly complex real-world problems.
And thinking about that roadmap the paper laid out, what breakthroughs, maybe in orchestration, memory, or safety, do you feel will be the absolute game changers needed to unlock the next level of AI capability discussed in this research? Definitely something to ponder as this technology keeps accelerating.
Thanks for joining this deep dive. See you in the next paper deep dive.